Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 200 gigabit network, all controlled by a brand new API, you've got everything you need to scale. Go to podcastinit.com/Linode to get a $20 credit and launch a new server in under a minute. And visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. Your host, as usual, is Tobias Macey, and today I'm interviewing Daniel Goldberg about Infection Monkey, an open-source system breach simulation tool for evaluating the security of your network. So, Daniel, could you start by introducing yourself?
So, my name is Daniel. I'm a security researcher at a cybersecurity company called Guardicore. In my day-to-day job, I look at malware, look at reverse engineer vulnerabilities, and try and analyze more weird, interesting network threats and the possible defenses. In my spare time, I work on the Infection Monkey, which is something that started out from, hey, wouldn't it be cool to, and turned into this rather cool open source project. It's pretty. We work on actually getting people to pass the basic bar of security, rather than just focusing all the time on sexy stuff. Other than that, I'm a programmer by trade and a hobbyist as well. This is what I enjoy doing, and you could say I have the luck of having my job is my hobby.
Yeah, I can relate to that, and sometimes I spend more time on the computer than I should. So, and do you remember how you first got introduced to Python?
Pretty sure, yeah, I remember that. I was 17, and a friend pretty much told me, you need to try this thing out, stop working with all these complex verbose languages. I was then a C# programmer, and he was like, go check out Python. And he sent some online tutorial to me and said, do this and then try out writing this kind of stuff in Python and then try it again in C#, and I got hooked. This was back in Python 2 something, and I was pretty much clueless, but I got a lot along with the language, and as they say, the rest is history. So a quick follow-up to the question you asked me. One of the advantages of starting out at just that time is I got a really high reputation Stack Overflow question was just being a complete noob question. But back then, Stack Overflow was all this new, and every question was like, oh, it's never been a duplicate before. So I got away with asking some really silly questions, and these days they're the canonical Stack Overflow answer. So you could say that's the advantage of starting out in the right time, in the right place, I guess.
It's funny how often that's the case, where you answer something that you think is simple and then it ends up being massively useful to everybody because it's a problem that everybody passes through at some point.
Yeah, it's also like it got me into a serious habit of not assuming that my question is stupid. I'll just ask. Worst case, somebody refers me to an answer.
And so can you discuss a bit about what Infection Monkey is and your initial reason for building it?
So the Infection Monkey, the fancy name, it's a breach simulation tool. What this practically means is it's a security tool that tests what happens when you're actually breached. Plain in a story ways, there's a lot of tools that say, are you vulnerable to different types of attacks? There's very few tools that say, okay, your network got breached, now what happens? Attackers got in, what can they get out? What can they do? Where else can they move from? And the idea was to write this simple tool that's going to check just the basics and be able to help you answer very simple questions such as, am I reusing passwords? Am I actually patching systems? Are my firewall rules actually effective? Because the security landscape is full, like an enormous amount of tools that are incredibly fancy and check the latest and greatest. And very few stuff actually works on, is the basics up and running? Are you doing the proper things? Are you even patched? When we started out this project, there was still a bunch of servers back from 2003 still vulnerable to decade-old vulnerabilities. And that was the prime motivation. Let's get the basics. Let's write a tool that doesn't assume you're under attack by the NSA, but you're under attack by a script kiddie, and most organizations are not prepared for that, regardless if they're a Fortune 1000 or they're a university in the middle of Washington.
And when you first started working on it, did you have any particular motivation for choosing Python as the language for implementation? Or was it just because that was something that you were familiar with? Or did it have any particular facility in the problem domain that you were trying to address?
So the answer to that is a few steps. One is, of course, it's easier to do it in the language you're more comfortable in. I'm fluent in C and Python, and I'm not going to write any complex networking tool in C. That's an invitation to a headache. And the second is Python's community approach of batteries included. There's a package for everything, meant I could really focus on get up and running quickly and not deal with stuff like a proxy server or an HTTP handling or anything like that. I could really get myself rather quickly to a point where, yeah, I'm attacking, I'm displaying stuff, I'm processing information in the backend. The entire, pretty much 95% of the code is written in Python. There's a few lines of C spread around. This is in the attacking part itself. And the key thing is, like, I can just focus on logic. If I need any type of library, somebody's already built it. The biggest alternative there was to say, am I going to build this on top of other offensive tools? And the answer was 95% of them are in Python, and only one of them is in Ruby, which was then the main alternative. And I was like, no, I'm not switching languages just for that.
And do you think that if you were to start the entire project over today, that you would make the same decisions in terms of the language implementation or the overall system architecture of it?
I think today, for one, I would definitely stick to Python, but I would seriously consider, in hindsight, building in Ruby, because that would give me the ability to build off what's considered today the gold standard of attack tools, Metasploit, and it's written entirely in Ruby. But overall, the decision to build in Python has been good. I have been bitten in a bit by the decision to build it in Python 2 and not start out from scratch in Python 3. I'm getting less support for stuff I want to do today, which is async communication, and modern libraries are becoming more and more Python 3 only. But overall, I'm pretty happy. We are having downsides of just designing it to be quick and dirty, and now as the project grows, you can start paying the price for all these design decisions you made a few years ago.
And so with that, can you talk through a bit about how the project is actually implemented and some of the architectural decisions that you made early on and how those have evolved while you've been working on building and maintaining the project?
So I'll try to touch on this different directions. The infection monkey is built of two main components. One is the monkey itself. That's the code that actually goes and attacks computers and propagates. And the other is the Monkey Island, which is a command and control server in security speak. It configures and controls the monkeys remotely. It displays a user interface to let the user configure the monkey and track what it's doing and see the results. And probably the biggest pain that we have is those are two privately separate systems. They don't share any code, which makes it far harder to expand anything, because the monkey, you want to have, it has a bunch of capabilities of how it can attack new machines. And probably the biggest design decision I'm regretting today is it's not very easy to plug in new features. Modern tools have pretty much like, oh, you just plug in, you leave a single Python file or module in the right place, and your code just knows how to display it and handle it. We're far off from that. I end up having to modify a lot of files in different places to get new features in and to propagate all the way to the user interface. The user interface itself is also a mix of, the backend is entirely Python, but we ended up building the front end in React, which is a JavaScript-based framework. And that's been pretty frustrating because we end up having to define the same structures and the same interfaces again and again. I'm not sure what would be a better solution, but that's definitely something we're eating a lot of pain over.
And in the particular problem domain that you're addressing with penetration testing, that's typically an area that requires a fairly substantial amount of knowledge and experience in terms of the security practices and the ways that exploits are written and executed. So I'm wondering what have been some of the most difficult aspects of building a system that is intended to automate a lot of that process and making it usable and accessible by people who don't necessarily have that same level of expertise.
Probably the biggest challenge is this means saying no to a lot of features that people want me to add or stuff I want to add. Because in order to have an easy to use tool, this needs to be a simple and safe tool. Simple means I don't need to involve you as the user with all the little details of what exact exploit am I running, with what parameters, and how exactly do I separate between Windows and Linux and different types of Linux machines. And safe means you need to be able to run this in your network and say, okay, this is safe to run, this is good enough, and you're not worried that it's going to crash your servers or it's going to take up too much CPU time. And this means that a lot of the more advanced stuff is just not in the monkey. I cannot add latest and greatest complex exploits because they have a probability of success. And the difference between my automated tool and a human penetration tester is the human penetration tester can call ahead and say, I might crash the server. Is that going to be okay? The probability is 1 in 1,000. If it's an automated tool, it can't ask those questions. So we decide to err on the side of caution and say, I'm not doing that. I'm not adding these attack exploits because I don't have a way to get the user's consent in real time. I don't want to have a situation when telling him, yeah, your network stopped working because you ran some unsafe feature. The other part is, how do I give the right information? I don't want to overload the user with a lot of technical details. I want to give the user very simple, here's the to-do list of what you need to do in order to fix your network. And that requires a lot of creativity in how do I phrase the results, what exactly am I going to tell the user. I don't want to tell him the exact details of how I breached something. I want to tell him this is what you should do. You should patch the server. Here's the exact command you need to run.
And in the security space, in particular, there's a lot of constant motion and evolution in terms of the vulnerabilities that are present in various systems. And I'm wondering what mechanisms you're using to keep a deployed instance up to date with new exploits so that you can test for them in the systems that are being run through the infection monkey.
Okay. Unfortunately, the short answer is currently I don't have any sort of auto update system. This is something I do want to do later on, probably in the next version I'm going to release of this tool. The reason is twofold. One, I haven't gotten around to it. The second is it's a lot harder to convince people to run in these tools. People might be happy running open source tools, but if you tell them this is an automated hacking platform and it's going to auto update itself remotely, then a lot of people I've talked with have been freaked out of like, how can I trust this? How do I know you didn't put a backdoor? How do I know this isn't going to suddenly change and start running around in my network? People have a far higher skeptical bar of running this sort of software. So I'm very careful in how am I adding any sort of communication with the outside world by this tool. For example, currently it doesn't talk with the internet at all. If you install it, it's going to run on your network. And the most it's going to do is it's going to try and talk to Google to see if it's internet connected. But I don't do any follow-up of that. So unfortunately, the answer to that is no. The more interesting answer is security-wise, it's rarely the latest and greatest. We hear again and again of hacks happening because companies just don't patch their systems in time, not with anything up to date, but years old stuff. You might have seen in the news all this NotPetya stories going around. There's been a recent story going around covering the incident again. Everything that happened there was due to password reuse and lack of network segmentation. There was no modern tradecraft or latest and greatest exploit happening there.
And some of the other systems that I've come across that seem to be in a similar space to what you're doing with Infection Monkey are things like Nessus or Nexpose. So I'm curious how the work you're doing with Infection Monkey compares or contrasts to those.
We're in a similar space, and Nessus is easier to explain. The biggest difference is Nessus is a vulnerability scanner. It looks at a machine in your network and goes, according to what I can discover remotely, you're vulnerable. What that means is that it doesn't do anything active. It just tells you, I could have breached in, but we don't know what happened. And the difference compared to what I do is by actually trying to exploit it, I'm not just saying, are you patched or not? I'm also asking, is your security software working? Because you might be unpatched, but your security software is good enough to detect and block my attack. It could also be that you're all considered very safe, but because of password reuse, it can still break in. And once I've broken in, which is a default assumption today in security, then are your internal security solutions actually working? Like, your companies today are paying millions of dollars a year on so many different security products, and they're not getting their money worth because it's very easy to bypass them. So the infection monkey goes and says, I'm going to be the dumbest tool on earth, and we're going to see if your software picks it up. And the answer is, unfortunately, to that is usually no. A lot of these tools that exist commercially just don't detect the simplest possible attackers. And that's a big difference. Like, I'm not just checking, can you breach, but I'm saying, assuming you've been breached, what happens next? Can you recognize where I broke into your software, it broke into your system, and I try to scan other machines, and you didn't pick that up? So what good is your security software? Because you have to assume at some point somebody's going to break in. So that's kind of like the difference between in the infection monkey and most vulnerability scanners.
And so when somebody is running a scan, what are some of the types of vulnerabilities and information that the infection monkey can discover and exploit? And how does that information then get relayed back to the user once the scan is complete?
Okay. The infection monkey does a few different layers of things. One, it tries to exploit the local machine it finds itself running on by stealing information. For example, password credentials, SSH keys, all these types of secrets that you keep on a specific computer. It then tries to scan the local network and attack different machines, either through a variety of password reuse mechanisms over SMB, SSH, or it tries to use classic, well-known vulnerabilities such as shell shock or samba cry or different web-based vulnerabilities that have been in news lately, like struts, or now we got an Oracle WebLogic exploit coming in. Once it gets to a machine, it breaks into a machine. It asks the question, can I, from this newly breached machine, communicate back home? Which is a placeholder for the question, can an attacker, after he's breached, exfiltrate data without you noticing, without you blocking it? So this is what the monkey ends up doing. And what we display to the user is some sort of summary saying, I managed to breach this machine with this exploit. Here are the exact steps you need to do to mitigate that. For example, patch this, block that, or note, or more high-level conceptual notes such as there's password reuse. I discovered a password used on this machine that I could use to break into that machine, and that makes no sense to do so, so please change one of these passwords. The whole focus is on trying to give the user actionable recommendations, not something generic of, oh, just patch your systems, but saying exact systems, the exact steps they need to patch, and what exact software is broken or out of date.
And then when you report that back to the user, do you use some sort of like happy unicorns and rainbows emojis so that they don't just immediately break down and cry and want to go hide in a hole with all the things that they have to patch?
I need to add the unicorn emojis. I'm going to bring that up in our chat room. I am so good. I'm happy that somebody is like pro having that kind of stuff. What we try to do, when I say we, I mean like a bunch of developers working on it, is to try to have very clear and understandable recommendations, not saying your entire network was breached, everything here is crap. Despite that sometimes being the case, but saying here's a very visual map of what happened over time, and here are the exact steps per machine, and we try to present it in a clear and like, not you screwed up or you're vulnerable to this, but this machine is vulnerable to XYZ issues. Each one of these could be fixed with 1, 2, 3 commands. But yeah, in any large network, that report is going to be somewhat scary. I think we try to make it better by having it be easy to break down. I have it easy for like somebody to read and understand.
And when you're running the scan and moving through the various systems and propagating throughout the network by leveraging some of these vulnerabilities, what are some of the techniques that you use to ensure that you don't accidentally cripple the system and that you can roll back the exploit that you're creating on the system?
The answer to that is twofold. One is we try as much as possible to avoid using anything that's statistical or likely to cause harm. This is why I'm avoiding and will continue to avoid adding any what's called memory corruption style vulnerabilities, because they are by definition statistical, and I don't want to ever be in that situation. The other is to have the monkey very well document the steps it's doing and to minimize its impact. I'm not leaving a bunch of files laying around the victim machine. It's all very clearly laid out. The monkey lives in this file. The log file is here. If you want to wipe it, we avoid any techniques that could destabilize the system, such as adding yourself to startup or running a CPU-intensive computation on a victim machine. Anything like that is sent back to the command and control server, which we assume and tell people like this should be a server that's actually running just the infection monkey island, our command control server.
And one of the other questions I have is, in the name, I'm assuming that that's a nod to the simian army approach that Netflix has taken with the idea of chaos engineering.
Yeah, so we start out going a lot from the chaos engineering approach of saying our basic approach is the same of saying what happens if you're breached. Don't just assume that's never going to happen, just assume it's going to happen. But we try and shy away from saying, yeah, we're just going to break your network and you're going to have to clean it up, because Netflix can pull it off because it's a huge company that can afford to have a few percent of what they're doing stop working. Most companies are not that well engineered. So our approach has been more and more to go, here's the very safe and secure method of running this. Here's the very well-defined results of what's going to happen. What we do leave open, and that's just how their network is going to be let out, is just how far the monkey will breach, how many steps will it take inside your network, but even that is very controllable. You can tell it, go up to here and no further, or these are the machines you should never touch.
You mentioned that you avoid exploits that are statistical in nature or that have a high probability of permanently affecting a system. And it seems that in some cases that might actually be useful to run through those tests as long as you can do it in a controlled non-production environment. So have you considered adding some sort of flag that you can set to say, with big warning letters, I understand that I'm going to break everything, to give people that additional information about whether they're exposed to those particular types of vulnerabilities?
So the break glass in case you want to do something feature is something we've thought about. I'm not saying I'm in principle opposed to it, but we're in the end a small open source project. It's not like there's 10 people working on this full time. And I think I want to work on features that people are actually going to use instead of something that I'm necessarily going to have to hide behind warning buttons. If somebody's going to come up and say, hey, look, I implemented this, here's the pull request, yeah, I'm going to take it right away. But I'm currently thinking there's so many more logical exploits and types of attacks that I'm still not near done with that I don't feel like I need that to get it around. Networks today are pretty much full of they're like Swiss cheese today, even without doing anything fancy.
And are there any aspects of network security or system vulnerabilities that Infection Monkey is unable to detect or analyze?
We pretty much avoid anything relating to what happens on the endpoint machine itself. This is not a test for your antivirus software. We focus pretty much entirely on network and pretty much servers because honestly, that's where the interest is. And this means I don't deal at all with IoT machine devices. I don't do phones. This is very much focused on, you have your Linux, Windows data center, and that's full of holes before we start working on everything else. That might be in the future, but I'm saying I think this is more than enough to chew off, and most people worried really about security are worried about that stuff, like where they keep their data.
Once you start branching out into phones and IoT and edge devices, you might need to start subspecies versions of Infection Monkey. Maybe the IoT can be the Infection Capuchin.
Yeah, I'm not... With a lot of stuff, I'm not opposed if somebody comes up and we were now working with the Google Summer of Code we worked over the summer, and somebody came up and said, I want to add some exploits, and I'm like, even if it's not part of the stuff I most want, yeah, come in ahead. That's the fun part of an open source project. You can come in and do stuff that fits in, and we'll just take it. But it's not something I'm going for. I am hoping somebody's going to fork the monkey and do cool stuff, but that's not happening, unfortunately, yet.
And for somebody who is interested in using Infection Monkey in their own environment, what are the steps involved in setting it up and starting it running?
So the easiest thing to do would be we offer in our GitHub page pre-prepared Debian packages, which will install the Infection Monkey command and control server on any machine. And you just set it up, browse, configure it with your network's IP address ranges, and just click play. That's going to be the simplest way to get up and running. We also ended up packaging a bunch of versions for like cloud vendors and stuff if people feel more comfortable with that. But the easiest way to get up and running is go to GitHub, download the package, and just get working. The workflow is pretty much you turn on the web page, you browse to the command control interface, it's all web. You tell it, I want to run it on this and this IP ranges. You click play, and it starts running up. Infection Monkey is also, it's not fully automatic, it's semi-automatic. So you're going to run a scan, you're going to see results. Hopefully you're going to fix them. Then you can run it again and again. It's not a complete leave it in the background. It's something that you run and see, see the results and go back again.
And does it keep track of historical results so that you can see over time as you progress to improve the overall security of your system? And then you can see where you started and where you've been so that maybe you can guard against regressions? That's
actually a good idea, which is a nice way of saying we're not there yet. We should do that. And I pretty much know how we're going to do that at the code level. But no, we currently don't have a way of saying, oh, look at how much you've improved the last few runs.
And when you're running a scan, is it generally done as a black box or a gray box where you either don't provide any sort of information or credentials ahead of time, or you can lay out, use these credentials and these are some of the hosts that I'm targeting?
So you can run it completely black box of telling it, here's the network, go play. But the most effective result is going to be if you do it a bit gray box of telling it, here are maybe some machines you want to focus on attacking, and here are some old or unused passwords that we might have not rotated out, like to precede it ahead of time with some details about your network, but still at a very high level. It's not, you don't need to know what your security is like in order to run the monkey. But the best results are going to be with still some sort of, so what I said before, like you can run a black box, but you're going to get the best results by being a bit involved in the process.
And for the reports that you generate, do you have any capability of maybe listing off in terms of compliance regulations that somebody might need to be focusing on, that these vulnerabilities will prevent you from passing these reviews or something like that?
The answer is going to be kind of yes, but we don't make it a feature in the report. We don't point out this part is PCI or HIPAA compliance. I don't think I know enough to say this is definitely going to fail your PCI audit. We do have some stuff like that, but not enough that points it out. So I wouldn't say this is not a replacement for a compliance scan, but maybe we'll get there. Like, this is an interesting idea, might get more people to use it. If I can say this is equivalent to running a compliance.
And are there any particular areas of expertise or knowledge that you would find particularly helpful for anybody who's looking to contribute to the project?
If anyone's planning to contribute, I would say I would want people who know about network vulnerabilities and know how to implement them. That's one group. The other would be good Python programmers who know how to use the data we have and analyze it. For example, the PCI stuff you suggested, we probably collect enough information, but just nobody has bothered to write up a report component that's analyzing these results and like seeing yes, no on PCI. We're just not analyzing it, which is a shame. Like, you're right, we should probably do that. Just takes more programmer time.
And what are some of the plans that you have for the future of Infection Monkey, whether in terms of community engagement or feature additions or bug fixes or anything like that?
So in the short term, we're right now, if anybody looks at the pull request activity in the code, is we're working on getting a release out of that's going to include a bunch of new attacks and analysis. A lot of it past the hash, and some recent web vulnerabilities have been making the rounds, such as a Hadoop remote control attack and stuff like that. However, long term, the goal is to just try and keep pace with what people worry about. We want to get it to securing Kubernetes clusters and understanding more the attack surface in containers, of saying, oh, okay, I have access to a Kubernetes control panel. What can I do with it automatically? How can I continue infecting the network? What's going to happen? That's a future plan, but generally the stuff that we always want is more exploits, more analysis, and based off the existing stuff. I would also say if there's anybody who wants to pick up the torch and do a rewrite so we actually can have easily usable plugins at the Python level, that's going to be a code design that we're going to need. Some it's not hard, it just takes a lot of code change, and code change is always hard when you're been into a project for 2-3 years. You start empathizing with your code, and you're like, I don't want to throw it all away already, but that's probably what should happen.
And are there any other aspects of the Infection Monkey project or network security and vulnerability scanning or anything along those lines that I didn't ask about yet that you think I should have?
I think the question should be, why is such a simple project so effective, should always come up. Because the Infection Monkey, when you get down to it, is really testing the basics of network security. We're not doing anything that really requires a human pen tester. And the shameful part is just how many places that I end up seeing this run in don't pass the basic security bar. So many of them are just like, okay, we can't even get a handle on our own networks, and the Infection Monkey, without any thinking, just blows apart the network, and that's kind of a shame. The Infection Monkey is pretty much, it's a really cool project, but it's more like kind of a certificate of failure if it runs and succeeds in your network, and that's more, I don't know if scary or embarrassing is the right word to put it.
All right. For anybody who wants to follow the work that you're up to and get in touch, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. This week, I'm going to choose a band that I've listened to for a long time that it's called Darkest Hour. It's on the heavy metal side, so I'm sure a number of people won't necessarily want to listen to it, but if that's the kind of thing you're into, they're definitely worth a listen. They're very technical and precise in their sound, and they've been going at it for a while, so yeah, go ahead and check it out. And with that, I'll pass it to you. Do you have any picks this week, Daniel?
Yeah, I have a pick. I have probably the most influential 2-page I've ever read in my life, which is something I read out that came out of the University of Chicago, which is about how complex systems fail, where systems are not something that's human or machine necessarily, but they're all interconnected. And the paper is called How Complex Systems Fail. That's just the title. And it so clearly explains so much of what we're seeing day to day that works and doesn't work, that I'm really impressed and has completely changed my look at society in a way. But there's no doubt your music suggestion was way more fun. I'm going to listen to that.
It just depends on your definition of fun.
I'm Googling it right this minute.
All right. Well, thank you for taking the time today to join me and discuss the work you're doing with Infection Monkey. I'm definitely planning on unleashing it on my systems and seeing how afraid I should be. So thank you for that, and I hope you enjoy the rest of your day.
Thank you very much. Goodbye.